Okay, so now that we understand how the production of the firm works, let's introduce cost into our problem. Now, for this particular case, we are going to assume that all the inputs are variable, as we were assuming when we drew the isoquant for the firm. Now, the main cost of production will be the prices of the two inputs that we have been using, and that's labor and capital. The price of labor is going to be called the wage, and we're going to use W for it. And the price of capital is going to be called the rent, and we're going to use an R for it. Therefore, assuming all this, these are all the only cost of production, these two types of inputs, then the total cost function for the firm will be the total cost equals the wage times the labor plus the rent times the capital. Again, this equation said the total cost of production will equal the price of labor, which is the wage, times the amount of labor you use, workers, plus the price of capital, which we're calling rent, times the amount of capital you use, and capital is machine, plants, and equipment. Now we know that so far we've been doing the analysis of the firm using an X and Y diagram. We're putting labor on the horizontal axis and capital on the vertical axis, so we're going to continue to do the same thing. We're going to put labor on the horizontal axis and capital on the vertical axis. So we're going to put labor here, and we're going to put capital here. Right? Now, so going back to the total cost function, we can represent that total cost, this equation in this diagram by simply solving this equation for k, which is the input in the vertical axis. So we can do that by simply solving for k, and what you will have is k equals Tc over R minus W over R times L. All right. So this will give you all the combinations. If you put this on in the diagram, will give you all the combinations of capital and labor that you can purchase given particular values of wage, rent, and total cost. And you can simply put that in the diagram, and you will actually end up with a line like this. The value of this here is essentially all the capital you can use at the prices that you have. So this will be the intercept, the y-intercept, which is Tc over R. Down here is the horizontal intercept, which will be Tc over W. And then the slope of this curve is given by this proportion here, which is the ratio of the prices. So the slope of this curve will be W over R. So now you know kind of what happens when any of these variables change. So if the total costs change and the prices stay the same, what you will have is that the curve will shift. Either if the total cost increase, it will shift to the right, and if the total cost decrease, it will shift to the left. And then let's get rid of those. Let's do this to get rid of this one, so we can put more things. And then if the prices of any of these two things change, right? The price of labor, the wage, actually increase, then the curve will actually become steeper, right? Because W is in the top part of the equation for the slope. And if the price of capital gets more expensive, then what you'll have is the opposite. The curve will get flatter. So by using the variables and the equations that are ruling this curve, you actually will know what to do or how to change the curve if any of these things change. So you probably know this already, but this curve that we just drew here, since it has to do with the cost, we're given the name of the isocost. All right, so this is the isocost for the firm. And what we are going to do now in the next section is to put the isocost and the isoquant together to find the quantity of inputs that minimize the cost of production.